Question 2 is all about forces and Newton's laws. So we have a Jeep of mass 2375 kg pulling a trailer up a hill. They move at a constant speed, so that means there's no acceleration. The engine of the Jeep exerts a force of 4,400 newtons up the hill, and the force due to friction on the Jeep and the trailer are 1525 and 375. And we're asked to draw a diagram to show the forces acting on the Jeep. So first of all, we'll start with the forces on the Jeep itself. So I'm going to draw a relatively big diagram because there's actually a lot going on here. First most obvious one is the weight. So we have the weight, which you can then resolve if you want, although last year in the marking scheme they didn't give you any extra marks for resolving the force, but I would do it anyway, because you'll need to do it in the next part anyway. Because of the weight, there's also a reaction force pushing out. If I could draw a perpendicular line, there we go. We also have the engine exerting a force up the hill, so it's going this way. So we have the force of engine, I guess. Force of the engine. So you could write in the numbers, but last year in the marking scheme they used the words, so you should probably use the words so that they know what forces you're talking about instead of just giving random numbers. As you can say, this is the reaction. As well as that, we also have the forces of friction. So we have the friction of the Jeep and the trailer, both pulling it down. So we'll have two forces going down. We have friction of the Jeep. We actually have three. We have friction of the trailer, if I can fit it in. Friction of the trailer. And as well as that, if you think about this, we have the trailer, which I'm going to call T, and that's connected to the Jeep, which I'm going to call J. The trailer is being pushed down. Of course, the part of the weight is going to be cancelled out by the reaction force, but the other part of the weight, this part here, let me just do it in red, this part here, that's pulling it down the slope. So obviously if this is connected to the Jeep, that's also going to be pulling it down the slope. So we're going to have pulling down this direction as well. We're going to have the weight times, that'll be sine of theta, or I guess we'll say weight of trailer times sine of theta. Weight of trailer times sine of theta. So it's kind of hard to know how much they'd want or how they'd want you to lay it out, but this is a quite clear way of laying it out here. So that's what I do. Then in part 2, they just want you to calculate theta. So we'll just take another look at the Jeep, and we'll draw in the numbers now. So first of all, we have the weight going down, of course. So that'll be the weight going down. So it's mass 2375, so it'll be 2375g will be the weight. So 2375g. If we resolve it, we have theta, we'll have 2375g cos theta, 2375g sine theta. I'm sure if you wrote the forces like this up there, they wouldn't mind, but just to make it really clear to show what each force actually is instead of just a number. The reaction is also acting on it, isn't super relevant here though. The force pushing it up the hill is going to be the force of the engine, 4,400 newtons. And then pulling it down the hill, we have these three forces. So we have both the frictions and the weight of the trailer times sine theta. So what we'll have is the frictions. So I'll actually write these separately here. So I'll have the friction, just to show all my work. It's going to be 1525 and plus 375. So if you do that on your calculator, it's 1525 plus 375. It's 1,900 newtons. But then we also have going down, if we think about the trailer again, that'll be, so the weight of the trailer has a mass of 350 kg. So we'll have 350g as the weight. And then we have this 350g sine theta here, and that's going to be pulling, obviously because it's connected to the Jeep, it's going to be pulling the Jeep down the hill with the 350g sine theta there. Since we know that it's traveling at a constant speed, we know that the acceleration is 0, so we know F equals ma. but that's equal to 0 because there's no acceleration, and that's going to be equal to the sum of the forces. So I'll take up the hill as positive and down the hill as negative. So we'll have 4,400 minus, so we have the weight of the Jeep itself, 2375 G sine theta, minus 350 G sine theta, and then also minus 1,900 newtons for the friction. Sorry, that's 4,400. It kind of looks like a 6, just make it clear. I'll get my G's and sine thetas onto the other side and keep my forces onto this side. So we'll have 2375 plus 350. So on the left side, we'll have 2725 G sine theta equals 4,400 minus 1,900. That'll be 2,500 newtons on the right-hand side. So then we can just do some quick rearranging. We can say that sine theta is equal to 2,500 over 2725 G, which means that theta is given by the sine inverse of 2,500 all over 2725 G, which if you put that into your calculator, you'll get about 5.37 degrees as your answer for the angle theta. In part B then, we continue with forces with a pulleys question, very kind of typical of what it would look like on the old exam papers. So we have this pulley system, 6.3 kgs, and we know these two weights. They release it from rest, and we're asked to show on separate diagrams the forces on the pulley and each of the weights. So we'll start off with the weights. So we'll start off with weight 1. So obviously we'll have its weight pulling it down, and its weight is going to be, well, I'm just going to write weight, make it clear again, and then we also have the tension in the string pulling it up. For the second weight, it's the exact same. We have weight pulling it down and tension pulling it up. You can write in the numbers if you'd like, but last year, again, they didn't want you to. And then finally, for the pulley, kg, it has the weight pulling it down. And then it has, because there's string on either side, the force pulling it up is equal to 2t, not just t, because we have tension pulling it up here and tension pulling it up here. So they are all the forces acting on the things. Then in part 2, we're asked to calculate the tension in the string. So what I'm going to assume is as long as you assume the direction of the acceleration and you keep it consistent, it doesn't actually matter if you assume the wrong direction. So I'm going to assume that the two weights are going to go up. So let's assume that this is going up. So the left one's going to go up with an acceleration of A. The right one's going to go up with an acceleration of B, I'm going to say, which means that the middle one will go down with an acceleration of A plus B over 2. So that's the kind of setup we have. So now we can do F equals ma on both. But before we do that, we don't know, to use F equals ma, we need to know the mass. We don't know the mass of this, but we do know the weight. So for W1, we know that weight's given by mg. So we can figure out what the mass is. So if we have 24.5 equals mg, which means that the mass will be 24.5 over g, which is 9.8. And if you put that into your calculator, you get 24.5 over 9.8 is 2.5 kg. I do the exact same thing for weight 2. The mass is given by the weight over gravity, 9.8, acceleration due to gravity, and weight 2 was 44.1, all over 9.8. That's going to be 4.5 kg. And now we can go. So F equals ma. We're going to do this for weight 1. F equals ma, and we're assuming a is going up. The acceleration will be going up. So we'll have m is 2.5, a. That's going to be equal to, so we have tension is up, so positive, minus, and then the weight 1 is 24.5, given in the question, minus 24.5. Do it for weight 2 as well. We know that F equals ma. This time the mass is 4.5 and the acceleration is b. And again, we'll have t, the tension minus the weight. Tension minus, and the weight for this is 44.1. And then finally for the pulley, F equals ma. And because it's accelerating downwards, we're going to use a negative. So we'll have minus, and then the mass is 6.3. And the acceleration is a plus b over 2. And that's going to be equal to, so we're taking down as negative again, so we'll have 2t minus the weight. 2t minus, and then the weight is 6.3 g, because the mass is 6.3. Now, in order to get t by itself, we can replace this a and this b using these equations. So we can say here that a is given by 2t minus 24.5 over 2.5, and here b is given by t minus 44.1 over 4.5, and we can sub these into here. So we'll have minus 6.3, I'm going to take the 2 out for ease of access. So now inside this bracket, we don't need to worry about that 2, we just need to worry about the a plus b. So we'll have t minus 24.5 over 2.5 plus, and then b, t minus 44.1 all over 4.5 equals 2t minus 6.3g. I'll just do this, I'll multiply by 2 across, I guess, and then inside this bracket, I'm going to kind of separate it. So t over 2.5 plus t over 4.5. So if you do that, so 1 over 2.5 plus 1 over 4.5, that'll give you, and I'll do this in a second. So I'm actually not going to do anything and just worry about the brackets for now. So when you add the t's together, the 1 over 2.5 plus the 1 over the 4.5, you'll get 28t over 45. And then when you do minus 24.5 over 2.5, minus 44.1 over 4.5, you'll get minus 19.6 when you do that. And it's still equal to 2t minus 6.3g. So now we can get the t by itself. So we can multiply and divide by this. So we get the 28t over 45 minus 19.6 equals, so multiply it up by the 2, we'll get 4t minus 6.3g, and then divide by the minus 6.3, if we bring that down. And then we can bring the t to the other side, so this will make it a minus, so then it'll become a plus. So 28t over 45 plus 4t over 6.3 equals, and then this minus and the minus will make a plus, so we'll have 6.3g over 6.3, that's just going to be g, and then plus 19.6, and then we can get a number on this, so we can say 28 over 45 plus 4 over 6.3, that's going to be 44 over 35, and that's still multiplied by the t, equals g plus 19.6. So that means that t equals 35 times g plus 19.6 over 44. And if you put that into your calculator to get an exact number on it, we'll have 35 over 44 times 9.8 plus 19.6. You'll get that the answer is about 23.34 newtons as the tension of the string. Right, sorry, I made a mistake there. This 6.3, when you multiply by the 2, I forgot to multiply this by 2. So 6.3 times 2 will give you 12.6. So that should have said 12.6g there. That should be 12.6. So then 12.6 over 6.3 is just 2. So instead of g, this will be 2g, because 12.6g over 6.3, that's 2g. So we'll have 2g here, 2g here. And then when you put that into your calculator, what you actually get is 35 over 44 times 2 times 9.8 plus 19.6. You get about, as your actual answer, 31.18 newtons. So sorry about that. That should be the correct answer now.